Jai Hind everyone. My name is Anuradha Dhumale from Computer Science and Engineering Department of Ajay Kumar Engineering College. Today my subject is blockchain architecture and design, and my topic is introduction to blockchain technology. In previous lecture we saw that what is blockchain, about the introduction of the blockchain. Now we will see in this lecture that how blockchain works. First of all, this is the architecture for the blockchain. Now, in the first, the transaction is requested and authenticated. After that, a block representing that transaction is created. We saw that the whole transaction is stored in a block, and that block is linking to one to another, that is which is forming the blockchain. After that, the block is sent to every node. This block is created. After that, this block is sent to the every node. In a decentralized network, there are different types of node, different types of peers are available, which is having the authority to access the database, which is having authority to control that transactions. So this block is created and sent to the every node of the decentralized network. This is the decentralized network where each node is presented at the different locations. After that, node validate the transactions. Node receive the reward for proof of work. Here some puzzle is given to the peers. There are different types of peers are available in the network, like endorsing peer, ordering peer, validating peers. These there are to validate this transaction. To validate this transaction, the one mathematical puzzle is given to the node. Every node is try to solve that puzzles and reach to the nonce. Nonce is nothing but the number ones, which is generated by every node. This is checked by the server. If that node is if that nonce is correct, after that the reward is given to that particular node or particular peer. After that, the block is added to the existing blockchain. The nodes which are present in this decentralized network have give the agreement for the transactions. They give the agreement for adding the block to the blockchain. So after that, the block is added to the existing blockchain after getting the agreement of this peer, which is available in the decentralized network. The update is distributed across the network. When the block is added to the network, when the block is added to the blockchain, new block is added to the blockchain, at that time all the updates all about this blockchain is updated in this ledger. There is a ledger to every node which is present in the decentralized network, right? Here in this decentralized network, with this node, with them, they have the record that is called the ledger. Ledger is nothing but the record books. That in that record books, all the informations about the transactions, all the updations about the transactions are here updated. And after that, the transaction is complete. Now, step 1, record the transactions. A blockchain transaction shows the movement of physical or digital assets from one party to another in the blockchain network. It is recorded as data block and can include details like this. In one block, there are different types of informations like who was involved in the transactions, what happened during the transactions, when did the transactions occur, where did the transactions occur. See here, first who was involved in the transactions, after that what happened during the transactions, when the transaction is happened, what happened during these transactions, when did the transactions occur, at what time the transaction is occur, where did the transaction occur, why did the transaction occur, how much of the asset was exchanged during that transaction, When one transaction is happened from one party to another party, then it is recorded that how much of the assets was exchanged, how many preconditions were met during the transactions. This is the first step of the blockchain architecture design, that is nothing but the record the transaction. Second is gain consensus. Consensus is nothing but the agreement. When all the peers, all the nodes are presented in the decentralized network, consensus is more important. Agreement of all the nodes are very important. So the second term is the gain consensus. Most participants on the distributed blockchain network must agree that the record transaction is valid. Every node of the decentralized network, every peer of that network have to be give agreement for the valid transactions. Okay, depending on the type of network, rules of agreement can vary, but typically established at the start of the network. The third step is links the block. When agreement is done, when every node is give their consensus for that block, then that block is linked to the another block. So once the participant have reached the consensus, when the agreement is done by all the peers, transactions on the blockchains are written into blocks. Whatever transactions have to be done, that transactions are written in the block. That transaction is stored in the block, equivalent to the pages of the ledger book. With that block is equivalent to the pages of ledger book. Along with the transactions, a cryptographic hash is also happened to the new block. This is the very important term, that is the hash value. Hash value is used for the uniqueness of the block, and that hash value is attached with that transactions in the block. The hash acts as a chain that links the blocks together. When we added the blocks to the another block, in every block there is a hash value. The next block stores the previous block hash value, so that there is a linking is done. Okay, one block is linked to the another block with the help of hash value, which contains the hash value of the previous block. If the contents of the block are intentionally or unintentionally modified, the hash value changes. When some updations are done, some modifications will be done by any peer or any user, then there is a hash value which is restricted the peers to modify, because this is the key feature of blockchain, that blockchain is immutable. That means no record, no transactions will be deleted or modified. So hash value will be changed here, providing a way detect data tampering. Link the blocks, thus the blocks and chains links securely. So that what happen here, if hash value changes, so we know that the data is tampered here. So this we will get the more security here, and you cannot edit them. With these features of immutable, we cannot edit the ledger, we cannot update or modify that ledger. Each additional block strengthens the verification of the previous block, and therefore the entire blockchain, this is like a stacking wooden blocks to make a tower. Okay, you can only stack blocks on top, and if you remove the blocks from the middle of the tower, the whole tower breaks. This is the example of what exactly blockchain is done, what exactly work of the hash value in the blocks. Share the ledger. The system distributes the latest copy of the central ledger to all the participants. Here, the decentralization is the key feature of blockchains. With this decentralization key feature, the ledger is shared with all the peers. Instead of relying on the third parties such as financial institutions to mediate transactions, member nodes in a blockchain network uses consensus protocol to agree on a ledger content and cryptographic hashes and digital signatures to ensure the integrity of the transaction. To maintain the integrity of the transactions, here the hash value and the digital signature is used to authenticate the user, to only give the access to the authorized user here. Consensus ensures that the share ledgers are exact copies and lowers the risk of fraudulent transactions, because tampering would have to occur across many places at exactly the same time. Okay, tampering will be done at many different places at the same time. Cryptographic hashes such as SHA-256. SHA-256 algorithm is used for the hashing here, for the uniqueness of the for keeping the hash value. SHA-256 algorithm is used here. After that, ensure that any alteration to transactions input A1, the most minuscule change results in a different hash value being computed. Meaning of this that if we are changing some minimum data or some minimum changes in the ledger, that hash value will be changed. So for this, here SHA-256 algorithm is used. The decentralized peer-to-peer blockchain network prevents any single participants or a group of participants from controlling the underlying infrastructures or undermining the entire system. Same, the decentralization is used here so that the authority no single authority is here. Everybody included in the decentralized network can access this data, can access these transactions, can update their ledger and have full authority to access that transactions. Participants in the network are all equal, adhering to the same protocol. They can be individuals, they can be state actors, organizations, or a combination of all these types of participants. Okay. Now, this is the structure of blockchain. This is the structure of blockchain where every block is linking to another block. Here, block 1, block 2 and block 3 are linking one to another block. In each block, there is some information is stored, like here is the block 1. Block 1 is having block 1 hash value, previous block hash value, nuns is number ones, which is generated by peers. They solve the mathematical puzzle here and generate one number, that is number ones, which is unique. And if that number is checked by the server and that number is matching with the hash value, then they will get the rewards for this number. Okay, after that, here the data. Here, what type of transactions, all the type of transactions which is happening will be stored in this section in the form of Merkle tree. Merkle tree. Okay, here the transactions are done. Okay, so this is the structure of blockchains. More clearly, we can see here block n-1, block n and block n+1, which is linking to one another. Block n-1 is linked to block n is linked to the next block, that is block n+1, which is having two sections, that is the header section and the transaction data. In the header section, hash value of hash of block header n-2. Okay, previous block hash value. After that, timestamp of that block, nuns value, which is generated by peer. Hash of block n-1, the block is n-1, which is having its own hash value that is stored in this section, that is hash of block n-1. After that, Merkle root, Merkle root is stored in the transaction data. Whole the Merkle tree is here. This Merkle tree is having all the type of transactions stored in this Merkle tree. They are, if the same type of transactions are here, then that Merkle tree is combine his leaf nodes to the root node. Okay, these are the leaf node and this is the root node. So this root node it's stored here in the Merkle root. Okay, so only H1, 2, 3, 4 this data is stored in this Merkle root, which shows all the transactions which is happening here. So this is whole the structure of block which is linking to one another. Now, what is the work of header? Here it is used to identify a particular block in the entire blockchain. It handles all blocks in the blockchains. Okay, header sections which is used to identify a particular block which is in the blockchain. It handles all blocks in the blockchain. A block header is hashed periodically by miners by changing the nonce value as a part of normal mining activity. 3 sets of block metadata are contained in the block header. Second is previous block address, previous hash value of previous block we stored in this section. It is used to connect the ith block to the I plus 1th block to the ith block using the hash. The previous block is linked to the next block with this hash value. In short, it is a reference to the hash of the previous block in the chain. Okay, we stored the previous block hash value in the current block for the linking the blocks, for linking one block to the another. Timestamp, it is a system that verifies the data into the blocks and assign a time or date of a creation of a digital document. When we create a digital document or when we do the transactions at that time, that timestamp, that date, that time will be stored in this section. That is the timestamp section. This is nonce, which I told you previously that nonce is nothing but the number ones which is generated by the peers. Nonce value is generated by peers by solving the mathematical puzzles. A nonce number which used only once. Okay, it is a central part of the proof of work. The nonce value, the main work is done in the consensus algorithm, that is proof of work algorithm. Here the nonce value is generated in the block. It is compared to the live target. It is smaller or equal to the current target. People who mine, test and eliminate many nonce per seconds until they find that value nonce is valid. Okay, they generate the number repeatedly until when the number which is matched with the nonce value. They repeatedly doing the they repeatedly solve the puzzles. After that, Merkle root. Merkle root is a cryptographic hash that represents all transactions in the block of blockchain. It is derived from a Merkle tree. It is derived from the Merkle tree. Merkle root is a cryptographic hash that represents all transactions in the block. Okay. Here, in this Merkle root, all the transactions are stored. What exactly transactions are done in the block, that will be stored in this Merkle root. It is derived from the Merkle tree, which helps efficiently verify the integrity of large sets of data like blockchain. Blockchain, this is similarly architecture which we see previously. Block, nonce. This type of nonce value is generated here. Here is the data, what type of transactions are done here. This is the hash value of previous block and this is the hash value of the current block. Okay, now the core components of the blockchain architecture. There are certain components of the blockchain architectures which include, that is node, transactions, block, miners and consensus. consensus, and this is the node. First node having the server computer and the user transaction, that is smallest building block which is having data structure for a set of transactions, and miners specifies nodes which performs the block verification process. These are the miners, these are the peers which peers solving the mathematical puzzles. They are called the miners here. Consensus set of rules to carry out the blockchain operation. Now we will see what is exactly the work of node. User or a computer within the blockchain architecture's independent copy of the, what is the node? What is mean by node? Who are the nodes? Nodes are nothing but the users or computer within the blockchain architecture, which the computer which are present in the decentralized network, that is called the nodes. Each has an independent copy of the whole blockchain ledger. Every node is having their digital ledger, their record book to update the transactions, to see the transactions. Okay. After that, what is transactions? This is smallest building block of blockchain system. Records or information is stored here in the transaction that serves as a purpose of blockchain. Transaction, that is all the type of data which is routed in the decentralized network. Okay, what happened in the transactions? We transfer some money, we transfer from some money from A to B. That money, that asset, that value will be the transactions. Block, a data structure used for keeping a set of transactions which is distributed to all nodes in the network. What is chain? A sequence of blocks in a specific order. Miners, specific nodes which performs the block verification process before adding anything to the blockchain structure. They have to perform some verification process before every node added to the blockchains. We cannot easily take a block and add to the blockchain. No, we have to do some process, we have to do some procedure for that block added to the blockchain. After that, consensus protocol, a set of rules and arrangement to carry out the blockchain operations. Hash is nothing but the unique key that identifies the block. Hash value is the unique key that identifies the block. Previous block hash, the hash address of the previous block to the which the current block is connected. The hash address of the previous block is used for the connections, for linking the block. Private key, a cryptographic versions of identity, is a unique identifier of the candidate and can enable a person to perform a digital signature. Here, for the digital signature, a customer can use their private key here. Public key, a cryptographic key which helps to identify the node in the blockchain network. Okay, to identify a node, we use the public key. If someone sends a data from A to B, then that data will be in the encrypted format. Okay, if we have to decrypt this data, we have to see the original data what A has sent, then we can decrypt that data by using the public key of the node A. So here public key will be used for the decryption. Peer-to-peer network, the group of nodes who are a part of blockchain. Network tokens, what is the network tokens? The cryptocurrencies, for example, bitcoins, can be used to incentives blockchain transactions in monetary terms. Smart contracts is nothing but the piece of code which is when the conditions are met, which is automatically executed. Can be thought of as a piece of code where all the rules are predefined. In the smart contracts, all rules are predefined to govern a transaction, and it is signed with the help of private key. These are the digital form of legal contract. Smart contract is nothing but the digital form of legal format. Okay. Cryptocurrency. Cryptocurrency is one of the use cases built on a blockchain technology. Within a few lines of code, you can create a code that identifies a physical good, real estate, assets, or access right. So these are the components of the blockchain architecture, that is hash, previous block hash, private key, public key, peer-to-peer network. Next is the digital money to distributed ledger. What is the digital money? The digital money which we used in the form of Bitcoin, in the form of Litecoin, these are cryptocurrencies, these are the digital money. Distributed ledger, these are the nothing but the record books which are stored to every node, which is stored towards the every node. The distributed ledger is a technological infrastructure and protocols which grants the access to multiple users, verification and modification of the records. These works can be done on multiple locations. Okay, distributed ledger, these works can be done in a multiple location or entities over the computer network. The distributed ledger is also called as the shared ledger or distributed ledger technology. So we will see this DLT, this distributed ledger, in the next lecture. Thank you.